so this is section 5.3. This is going to be part 1. This video is divided into 2 parts. So a little math humor there with, does this hat make me look normal? All right, so we're going to be doing kind of the same thing in StatCrunch. We're going to use the normal calculator, but this time the problem is going to give us the area, and we need to find the z-score. So on this first one, it says find the z-score. So remember, that is the number on the number line that corresponds to the cumulative area of 0.3632. Now, if it does not indicate whether we want to go left or right, then we're always going to go left. So unless it says to the right, or we're going to see one with top 10%, if there's no indication of direction, then we're always going to head to the left. So in this case, they told me the area. So I drew my bell curve, I filled in my area here, and I know that that area is 0.3632 based on the problem. In a minute, I'll show you how it's going to work with StatCrunch. The next question, again, we drew the bell curve, but this time they want to find the z-score. So again, we're looking for z that has 10.75% of the area to its right. So that's why this time we shaded to the right. And so that area is going to be 0.1075. We're looking for the z-score. Now I put the z-score on here, but you'll see how I got it on the next page. Okay, for this first one, we are going to ignore the table. Don't do the table. We are going to use StatCrunch. So let's take a look. We know that we're going to draw our curve. This one didn't tell us direction. This was the first one. And so therefore we know that we're going to draw our area to the left because there was no direction. And we want about 36%. So let's just shade in. It's just a rough magnitude here. So this is going to be 0.3632. Now the problem did not tell us anything about mean or standard deviation. So since they did that, we know that the mean is 0 in the middle, standard deviation is 1. So we're going to go to StatCrunch. We're going to go to Stat Calculator Normal. We're going to make sure there's a 0 in the mean, a 1 in the standard deviation. And because we know that we want to be heading to the left, we are going to use less than or equal to. So we're going to put that in. We're not going to put this next number in. We are going to put the area on this side. Okay, so the z-score is here. The area is here. And then once we put that area of 0.3632 in and you hit compute, then it's going to give you the z-score. So the z-score is right here, this negative 0.35, right? And so that is the number on the number line. That is where this shading ends. All right, let's look at another one. All right, so let's take a look at this. When they give me P with an 83 here, this is percentile. And so what this is telling me, we've done this one on another section, it's telling me that I want 83% to the left. So 83% is a lot. I'm gonna go ahead and shade all of this. My picture above is a little better. And so we're gonna let this be 0.83. And so at this point, we could, if we were trying to find the z value right here, I could go into StatCrunch. I'm gonna do x less than or equal to, because I'm heading to the left, leave this blank, and put 0.83 on this side. It would give me the z-score. But what I wanted to show you here is back to the that the area under the curve is 100%, or 1 if we're dealing with decimals. So here, if I have 83% on this side, that means I have 17% on this side, right? Because it would be 100% total minus the 83 would give me the 17%. So I just wanted you to see that of where together those two areas would give me 100%. Okay, so we're going to do this work on the next page, but we've got P5, so that's percentile again, and P with a 50. So let's go to the next page. Okay, so with P5, we want only 5% to be in the tail. It did not tell me one way or another if I wanted to go right, if I wanted top, so we are always going to go left if we don't have any other information. So that tells me that the area inside is going to be 0.05, and we're looking for the z. We want to find the z. This has already shown it. So if I go into StatCrunch and I put less than or equal to, and I put the 0.5 on this side, it's going to give me that z-score of negative 1.645. So the z is always on the number line. The area is what is shaded. Let's try 50%. Okay, so for P of 50, we don't really have to use StatCrunch. If we draw our curve and we shade half of the area under the bell curve, that's going to take us right up to the mean. And so the z-score would be 0, right? Because of symmetry, we're going to have 50% on the left of the mean, and then we're going to have 50%. I just lost everything I just drew. All right, let's try again. Whoops. Something happened with my board here. See if I can get it back. No, hold on. All right, let's do this again. So on this side would be 50%. I have a 0 here for the mean. On this side, I would also have 50% because of symmetry. And therefore, my z-score is actually going to be 0 for this problem. Okay, so we've already used this formula where we have that the z-score, we can find the z-score by taking the data point minus the mean over the standard deviation. Sometimes we're going to do this a little differently because we have different information. We're looking for the data point. We have the mean, we have the z, and we have the standard deviation. And so we're able to use this formula, and it's on your resource sheet, excuse me. All right, so let's look at this problem. We've got a veterinarian who records all of the weights of the cats treated at his clinic. The weights are normally distributed, which is great. That means we can use the calculator normal if we need it. We also can use our formula here. And the veterinarian tells us that the mean is equal to 9, so that's great. And the standard deviation is equal to 2. So of all the cats that he treats, the mean weight is 9 pounds, and then it varies by the 2 pounds, so the standard deviation. So they want us to find the data value based on a z-score. So they gave me a z-score of 1.96. So I can actually put this right into the formula that's above. So the formula above tells me that, let's do it down here. I want to take the mean, which is 9, plus z, well, they told me z is 1.96, and then times the standard deviation, which is 2. If I pop that in my calculator, I get 12.92. So this is one of the chubbier cats. This is my cat. I have a cat. I think she's 20 pounds. She likes to be carried like a baby, but she's a beast. All right, now if we had drawn this, we would know that this weight was going to be a lot bigger than the mean because we're way over here, almost to 2 standard deviations away, right? Because we're at the 1.96. So of course the weight should be greater than the mean weight. Okay, so let's look at the next one. The next one was negative 0.44. So that one is going to be on the left, and therefore our data point should be less than, I can't get this thing to draw, should be less than the mean. So we put the mean, we put the z, we put the standard deviation, pop it in our calculator, and sure enough, we get 8.12 pounds. Okay, and that makes sense because we know, because it's a negative z-score, hopefully getting used to this number line, we know that the weight is going to be lower than the mean. Now for this last one, they took z equals 0. Well, z equals 0 is smack dab in the middle, and so that should be the mean. But if we put everything in, put your mean in, put the z value of 0, standard deviation of 2, sure enough, you're going to get the mean of 9. Okay, so this is just showing the same thing, just taking its time and from the book. All right, so we are ready for part 2. Go ahead and go to the next video.